Okay, so diagram 1 shows a satellite P orbiting the Earth at a constant height. So we begin with this gravitation question. The physics law that explains the force is, of course, Newton's universal law of gravitation lah. Okay, kalau Newton's first law, you're talking about inertia. Okay, this is obviously not the case lah, because of the words constant height, and also because there is a double force pulling. Okay, one is pulling the other. So it's universal law of gravitation. Just to recap, the formula for this is F equals to G m over r squared. Okay, the big mass and the small mass, or two masses lah. Okay, divide by r squared. Okay, so name the force F. The force F is the gravitational force. Okay, so the gravitational force, hold on, oh, sorry. Okay, gravitational force. Okay, so gravitational force. I think it's pretty simple because, well, okay, if satellite P orbiting, okay, at the same height, so the keyword is same height, around a planet with a bigger mass. Okay, that means if you take a look at the formula as I said just now, F equals to G m over r squared. Okay, what happens to the physical quantity in 1b, okay, which is asking what happens to F lah. So if we increase the mass over here, obviously the F also will increase. Okay, I think this is quite straightforward. I don't think there's really much to it, but the formula does help us lah. Okay, now satellite P experiences technical damage and falls towards the Earth. So suddenly they decide and then jatuh lah. Okay, so the question is, state what is the change to the gravitational acceleration. Okay, so for this, the answer for this is increases. Okay, the gravitational acceleration on the satellite P increases. However, okay, so I like this word lah. Okay, it says that it falls towards the Earth. Okay, that means it's not on the Earth, it's in outer space lah. So we have to go back to the graph. Okay, if you remember of the graph of the gravitational acceleration over the distance from the center of the Earth. Okay, so the shape of the graph first is a straight line like this. Okay, and then at a certain level, okay, it reaches a 9.81. Okay, and a 9.81 gravitational acceleration. And then after that, as it goes further and further away from Earth, okay, this is obviously R lah. R is this. Okay, this is R. Okay, so as it goes further and further away from R, we notice that the graph will decline like this. Okay, so since our object is at this particular place, which means that it's probably like around this region lah. So as it falls towards the Earth, it's getting nearer and nearer towards the R. Okay, which is why the gravitational acceleration increases until it reaches 9.81. Okay, probably a common misconception, which is not really a misconception, okay, is we always think that gravitational acceleration is a constant lah. Okay, sure, 9.81. But in actual fact, even if you move a little bit away from the Earth, the gravitational acceleration changes lah. It's a very small change. Okay, but we come back to this graph, which explains why the gravitational acceleration increases. Okay, if it is the gravitational field strength, this is a different story altogether. Okay, but the question is very good. It asks you about the gravitational acceleration to test you, okay, if you remember the shape of this graph. So please remember this. The further it is from the surface of the Earth, the gravitational acceleration decreases. But since it is going towards the Earth, okay, the gravitational acceleration will increase until 9.81. Okay, so this is the answer for this lah. Okay, number 2, radioactive decay series, okay, for the nucleus of uranium-238, okay, to radium-226. Okay, so the first question, I suppose, is radioactive decay, lah kan? Okay, what is the meaning of radioactive decay? Okay, so it is a process, okay, it is a process, oh dear, okay, process where an unstable nucleus, apa? Okay, process where an unstable nucleus, astaga, nucleus, okay, becomes more stable. Okay, menjadi lebih stabil. And how does it do it? Okay, it emits by emitting radioactive radiation. Okay, sinaran radioactive. So the key word for this is this. Kalau decay, okay, rebutan radioaktif, it's from unstable menjadi lebih stabil. Okay, itu tujuannya. So actually the answer for B is kind of the same thing also. Okay, dia mau menjadi lebih stabil. Okay, to become more stable. Okay, so if you can get A, you can get B already lah actually. Okay, but probably in terms of the definition, probably yang akan a little bit more tough. Okay, for for some, it's that you may forget this one lah. How does it become more stable? Okay, it becomes more stable by releasing some radioactive radiation. Okay, kind of like, I suppose you can say it's kind of like farting lah, kan macam kentut lah. Kau tidak stabil kan, then after you kentut, wow, okay, more stable. I suppose so lah. Okay, anyway. So, how many alpha particles, okay, and beta particles are emitted in this process? So, the key to this diagram is remembering that all these Sengit 2 boxes, okay, all these Sengit 2 boxes represents an alpha decay. Manakala, all the straight to the right, this one, 1, 2. Okay, notice that every arrow there is one interaction. Okay, so you don't look at the number of boxes, you look at the arrow. Okay, so for this one, okay, the pink one, this is a beta decay. So when you add it all together, there's one here, one alpha here. Okay, so there's 3 alpha and 2 beta. This is a very simple diagram to remember. Even if you don't understand what's happening, okay, just know that, okay, kalau ada yang saying macam ni, 2 boxes, this is alpha. Kalau dia ke kanan, 1 box is beta. Okay, so the answer for this is 3 alpha and 2 beta. Okay, this is a very simple diagram to remember. I hope it comes out because it's really, it's like a bonus question lah. Okay, write the decay equation of uranium-238 to radium-226. So we need to understand this. It starts from uranium-238 and it ends with radon-226. Macam mana dia menjadi begitu? Dia melepaskan, dia membebaskan 3 alpha, 2 beta. Okay, so let's start with the uranium-238. So this is uranium-238 and you should write the 92 also lah. Macam mana saya tahu 92? Sebab ada di sini. Okay, 238 di sini, 92 di sini. Sini uranium. Okay, adakah uranium-234 92? Ada. It's here. But this is a halfway point. So jangan pakai itu. Okay, take the starting point. So uranium-238, 92. Kita punya penghujung ini adalah radon. Okay, so dia akan decay menjadi radon 226. Take a look at the number at the bottom. What's the number at the bottom? 88. Okay, 88 plus 3. Okay, now we have to remember. I think I mentioned this in the previous class. Kalau alpha is what? Helium 42. Kalau beta is electron 0, negative 1. You need to write this. Okay, jadi dia adalah 3 helium 42 dan dia juga membebaskan 2 electron 0, negative 1. And don't forget our most important one, which is energy. Okay, this is a simple equation to write because all these numbers are in the diagram. The one that you have to really focus on is to make sure that you don't forget that alpha is 42 helium and beta is 0, negative 1 electron. Okay, Yeah, I think this is pretty straightforward. Nothing much to this. Okay, let's continue. Number 3, diagram 3 shows water spurting out at a distance. Okay, D1, D2 due to pressure. Okay, we see lah. Okay, we see this situation over here. So state the factor that affects. Okay, the factor that affects the distance of the water spurt. Okay, so this is liquid pressure. Okay, tekanan cecair. Tekanan cecair dia punya formula adalah P. Sorry, tekanan cecair. The formula is P equals to rho GH. Okay, rho GH, and don't forget that the rho over here, sorry, the H over here represents the depth, kedalaman. Okay, and when we say depth, okay, bila kita cakap pasal kedalaman, kita bukan bercakap dari bawah. The depth is always calculated from the top to here. So this is one depth. Okay, from the top to here, this is another depth. Okay, never say that the depth is from the bottom. The depth is always from the water level. So there are two factors, there are two main factors, okay, that affect the distance of the water spurt, because the distance of the water spurt is representing the liquid pressure. Okay, dia mewakili lah, okay, the liquid pressure. So it is affected by two things. One is the depth, okay, and of course, the other one is also the density. But, okay, listen, question says in diagram 3. In diagram 3, the one that is changing is the depth. You're still using the same water. It's not like one is oil, and if it's one oil and one water, then the factor is density lah, okay, ketumpatan. But dalam case ini, okay, the question is very clear. In this diagram, the factor that affects the distance is the depth. Okay, the depth of water. Okay, kalau kamu ada tempat, write down there lah. We reject the answer density sebab dia tiada kaitan dengan situasi ini. Okay, in this particular situation, you have to be smart about this. In this particular situation, okay, the density is not considered as this. If you say height of water, height. I think height is a little bit dangerous because usually we talk about depth. You know, yeah, height is like ketinggian lah, but depth is kedalaman. In Malay, is kedalaman. Yeah, I think height is not a wise answer. Depth is a better answer lah. Okay, thank you for the question. It's a good question. So as I said just now, density we cannot take into account because in this situation, it's the depth of the water that plays a role. Okay, sorry, 1 minute. Okay, so calculate the water pressure at R. I think this is a very simple, this one. P equals to rho GH. Our rho is given as 1000. Okay, standard for G is always 9.81. And the H, okay. At R, so at R, we're talking about this, astaga, sorry. At R, we're talking about this height, okay, from the top until this. So the R is obviously not 10, okay, cannot be. So how much is this? 30 minus 10 is 20 cm. However, okay, I know that the H is 20 cm, but because we're using SI unit, change it to meters. Never forget this. Okay, change it to meters. So you get 0.2. Okay, and then you will get this as 1962. All pressure is the same unit. Okay, so don't need to worry so much about this one. It's always Pascal. Okay, if you're used to using Newton per meter squared, this is also fine. Okay, but the normal unit we use is Pascal. Okay, so if you notice, it's pretty interesting. It's 3 marks. Okay, so the first mark is for changing the 20 cm to 0.2. Actually, the first, no, my mistake. The first mark is to identify the H as 20, even if you do it in cm. Okay, yeah, they're not so unkind. So even if you do it in cm, but you get that the height is 20, that's 1 mark. The second mark is using 0.2 meters and substituting the 3 values correctly. The final mark is the answer. Okay, the answer with the unit. Okay. Next, predict the distance of the water spurt. The spurt if the distance spurt if the water is replaced with olive oil. Okay, kalau kita tukar dengan what's olive oil, minyak zaitun. Okay, first thing we need to remember is go back to the formula rho GH. Okay, in terms of the olive oil, dia punya density sikit, dia punya ketumpatan adalah berkurangan. But water, the density is higher. So if the density over here decreases, okay, the distance of the water spurt will decrease because the pressure decrease. Okay, so the answer for this is decrease, and the reason for this is olive oil has a lower density. Okay, olive oil has a lower density. You can also say water has a high density. Either one is fine. Okay, but as I said just now, please remember in this particular case, the distance of the water spurting represents the liquid pressure. Dia mewakili, okay, the liquid pressure. All right, number 4. Diagram 4.1 shows a situation of a passenger riding a roller coaster, move from left to right, okay, when the carriage changes its direction. So if you've ever been on a roller coaster before, well, I don't know. Do you find it fun or do you find it suffering? I don't know. Okay, so anyway, the physics concept involved, obviously because the situation says that you're moving to the left and right as it changes direction. Okay, so we are talking about inertia. This is quite obvious. Okay, the concept involved here is inertia. And when we're talking about inertia, the law that is involved, okay, is obviously Newton's first law, okay, of motion. Okay, I want to say something about this Newton's first law of motion, or even the apa itu yang satu lagi tu, like the Newton's universal law of gravitation lah. Okay, because I feel that sometimes bila kita menjawab, we kind of take for granted certain things. Okay, I think that I need to mention this in case, okay, there's suddenly a very funny rule lah. Okay, if it is a law, principle, okay, all these things are yang ada nama yang besar makan. Okay, the punctuation is pretty important. Newton's first law of motion. Okay, the N, the F, the L, and the M must be big letter. Okay, sebab dalam bahasa Melayu kita panggil ini sebagai kata nama khas. Okay, it's a proper noun lah. Okay, so we cannot just simply write small letter when it comes to law and principle. Okay, so make it a habit. If it is a law, if it is a principle, the name of a principle, write the first letter as big letter. Okay. So there's a reason why this sticker is there. Of course, when I was reviewing this paper, it's such a weird question. State one safety measure that needs to be taken to ride the roller coaster. Okay, so the safety measure is easy. Okay, I think the two most famous safety measures, anybody who's been on a roller coaster, you know this. You can either have a safety belt, use a safety belt, or safety, apa itu, usually they have a bar, right? Okay, they have a safety bar. Okay. Sometimes they also have the overhead one. Kalau if you've ever been to a ride yang dia naik ke atas kan, terus dia kasih jatuh kamu ke bawah begitu kan. There's this thing that it goes on your shoulder lah. Okay. I suppose you can call this a shoulder. Well, it's not a shoulder bar lah. It's obviously not a vest. Okay. Okay. The marking scheme says that it's a shoulder restraint. Okay, dia kasih sekat sajalah. Okay, it kind of stops you from moving to the front lah. Okay, but anyway, the safety measure is the easy part lah. Okay, I think the easiest part obviously is the safety belt lah. Okay, because even if you don't know what all these things are, kalau ada belt also, it's good enough. Okay, so the reason for your answer, okay, is I think the easiest reason, okay, is to avoid the passenger from being thrown out But I want you to put the concept in. Okay, thrown out due to inertia. Okay, the reason why he can be thrown out is because of the inertia, of his own inertia lah. Okay, bila dia pusing ke kanan kan, tapi kau masih bila dia pusing ke kanan, tapi kau masih lagi dalam kiri kan, so you may be, you may be thrown out. Okay, so I was looking at the marking scheme and it's quite interesting lah. They only accept the words thrown out. They don't accept the word fly out. They don't accept the word jump out, because okay, jump out definitely cannot lah. Okay, I think fly out is a little bit I don't know. I would accept fly out lah, like accidentally fly out. Okay, but maybe it's just this particular marking scheme lah. Okay, it's a little bit more strict. Okay, but I think what I want to emphasize, and the reason why I put this sticker over here with the ghost face and everything, is because I want to emphasize that bila kamu bagi sebab bahkan, try to put in some physics inside. Okay, so kenapa dia terbuang keluar? Kenapa dia tercampak keluar? Okay, it's disebabkan oleh inertia-nya. It's because of its inertia. That's why it's thrown out. Okay, the person doesn't fall. I think fall is really very unacceptable lah. Okay, thrown out is kind of the best answer for this lah. Okay. All right. Diagram 4.2 shows a roller coaster carriage, okay, with passengers sliding down the rail from X to Y. So we talked about this in the previous class. Energy change is what energy to what energy. Okay, so we need to know this, and this is actually from science, I don't know which form. Okay, there always seems to be one of these kind of questions, right, where they test you stuff that you're supposed to learn from, like science form 1, 2, 3. Yeah, there's always going to be this, because you cannot separate. Kau tidak boleh pisahkan physics daripada sains menengah rendah. It's still going to be there. You have to know this. Okay, so at a certain height, this is obviously gravitational potential energy lah. Okay, gravitational potential energy disebabkan dia ada ketinggian. At Y, since it is moving down, okay, it's going to be kinetic energy. Okay, so the energy change that happens is gravitational potential energy. Okay, change to kinetic energy. And it is okay to use the arrow, okay, to state energy change, because that's what we learned in Form 1. Okay, bertukar daripada tenaga ini kepada tetangga ini. So we always use arrow. Okay, so it's really not a big deal. Don't worry about this. Okay, calculate the energy at X. Okay, at X over here, if the mass and the carriage is 1,500. Okay, so gravitational potential energy is mgh. Okay, so the mass is 1,500, the G is 9.81, and the H is 15. Okay, sebab dia punya ketinggian sini adalah 15 meter. Okay, so our answer will be 220725 joules. Okay, I think the answer is exact lah. Okay, 220725 joules. This is pretty easy, except that, okay, so ini sama cakap this formula is not in your formula list. Okay, the formula list only contains hanya mengandungi formula daripada Form 4 and Form 5 physics sahaja. Anything else that you learn in Form 1, Form 2, Form 3, you are expected to remember. Okay, and so some of the things that you need to remember, okay, are things like the formula for potential energy, gravitational potential energy, kinetic energy. Okay, these are the basic formula that you must remember, because it's not going to be given to you during the exam. Okay, and so the next question, calculate the velocity. Since it changes from gravitational to kinetic, which means that the gravitational potential energy equals to the kinetic energy. Okay, I think this is a good this is a good opportunity lah, okay, so to revise again these two formulas, especially because they're not going to give it to you in the exam. So you have to know kinetic energy yang di sebelah kanan and gravitational potential energy di sebelah kiri. Okay, gravitational potential energy is 220,725. Ini kita sudah kira equals to half. The mass is 1,500 V squared. Okay, now when you do this calculation, don't forget to square root. Okay, so V you will get, okay, saya tinggalkan beberapa ruang, nanti kamu jawab sendiri. V equals to 17.155 meters per second. Okay, we're sticking to 3 decimal places as is our usual practice. Okay, don't forget the unit. But most importantly from this question, and there is always one question, at least one question, that tests you things that you're supposed to know from science from 1, from 2, from 3. We saw this in the previous paper when we were doing SBP. Dalam kertas ini pun kita nampak benda yang sama. Okay, there is always one question yang menguji kamu tentang apa yang kamu belajar dalam sains. Okay, so miss out these questions. Okay, don't like abaikan, alah, lupakanlah itu sains. Okay, so this is where it becomes important lah. Okay, number 5. Oh, actually we're going pretty fast today. The other day it took me so long to get to question number 5. Okay, jangan, don't jinx it. Nanti kan lama lagi. Okay. Diagram 5.1, 5.2 show the arrangement of apparatus experiment. Determine relationship between volume and pressure. I think I did this in the Terengganu paper. Okay, but in case you're not familiar, gas law dia adalah the segitiga lah, kan? This is P, this is V, this is T. Okay, anything in this direction is directly proportional. Anything in this direction is inversely proportional. Selain daripada itu, you should know that PV is Boyle's law, okay, VT is Charles' law, and PT is Gay-Lussac's law. Okay, this is a very, very simple this one. But don't forget, kalau kita bercakap pasal hukum gas, permulaannya mesti bagi jisim gas yang tetap for a fixed mass of gas. Okay, the beginning of every gas law starts with for a fixed mass of gas. Okay, definisi untuk setiap hukum gas. Okay, bagi satu jisim gas yang tetap for a fixed mass of gas, and then kamu cakap. So in this case, volume and pressure are the ones that are interacting. Okay, so kita tutup. Okay, kita tutup itu temperature sebab temperature yang menjadi constant. Okay, so we don't do this. We cover the this one, so PV. Okay, so question is, state the SI unit for pressure. So anticlimactic. Okay, SI unit for pressure is Pascal. Okay, you can answer PA also. I don't think it's a big deal. The other one is Newton per meter squared. Mana-mana pun boleh. Okay, any one of this is it's not a problem lah. Okay, compare the isi padu udara terperangkap, volume of trapped air. The volume of trapped air is here. Okay, I think it's very, very easy to see. Okay, 5.1 is more than 5.2. Reminding you once again, okay, if you can, please write the title at the beginning. Okay, at least volume lah. Sekurang-kurangnya tolong tulis volume. Okay, if you don't write volume or try at least write volume. I think this is a much better looking answer. Okay, the reading of the pressure gauge. Reading. Okay, if you take a look at here, reading sini kecil, reading sini besar. So this will be 5.1 is less than 5.2. Okay, reading of pressure. So we're seeing this relationship, okay, antara volume dengan pressure. The next question is the reading of the thermometer. Okay, reading of thermometer, 30 on the left side, 30 on the right side. This is a real no-brainer. Okay, the reading of thermometer, 5.1 is equal to 5.2. I think it's easy. This is a very easy compare question compared to the one that we did yang SBP hari itu. Okay, based on your answers, state the relationship between volume and pressure. Okay, if you take a look at this, since the direction is in different directions, okay, satu ke kanan, satu ke kiri, so we know that the bigger the something, the smaller the something. Okay, so the bigger the volume, the smaller, okay, the pressure. Ya lah, kasih habis lah, okay, of trapped air. Okay, the bigger the volume, the smaller the pressure of trapping. I think it's a very simple question. The physics law involved, obviously, this is Boyle's law. Okay, perhatikan sekali lagi, the B and the L is big letter. Ejaan nama saintis tidak boleh salah. Okay, Boyle. Okay, cannot be wrong. Tolong luangkan sedikit masa. Please memorize the spelling for scientist names. Cannot get this wrong. Okay, the funny names lah, like Bernoulli, Archimedes, Guy Lussac, all these people kan yang susah betul dia punya ni. De Broglie, oh my goodness, De Broglie is the worst. Or De Broglie, okay, all these are very, uncommon names, so, make sure you don't get the spelling wrong. Okay, if the piston in diagram 5.2 is pushed deeper, okay, what will happen to the pressure gauge? So, if I push it even deeper, means the volume kan akan menjadi lagi sikit. Okay, sikit saja. Okay, so if the volume becomes smaller, the pressure will increase. Okay, so we will have the answer for this increase. What will happen to the reading? Okay, just another reminder, I'm never going to stop reminding you of this. If the question is what will happen, never leave it empty. There's one of three choices. Bertambah, berkurang, tidak berubah. Okay, increase, decrease, unchanged. Okay, even if you don't know what the answer is, give it a shot. At least don't leave it empty. Okay, you cannot run away from gas law without talking about the kinetic theory of gas. Okay, so just to remind you, if you talk about pressure, okay, you must somehow kaitkan with the rate of collision. Okay, rate of collision between gas molecules and wall. Okay, wall of container. Okay, if you're talking about volume, okay, you're talking about the space. Okay, space that the gas molecules fill. Okay, berapa banyak ruang yang gas molecule tu boleh mengisi. Okay, and of course, if you're talking about temperature, okay, when you're talking about temperature, you're talking about the kinetic energy. Okay, kinetic energy of gas molecules. Okay, also you can say the velocity, okay, or the speed of the gas molecules. Okay, so whenever you talk about kinetic theory of gas, you have to talk about this. Okay, and so since we're talking about, okay, Boyle's law is pressure and volume. So we want to talk about this. Okay, so what happens when you push the piston down? Okay, when you push the piston down, the space, okay, the space that gas molecules fill decreases. Okay, ruangannya berkurang. Okay, when we push this one, the space dia punya ruang itu berkurang. Jadi, okay, what happens to the pressure? The pressure increases because the rate of collision between gas molecules and walls of container increases. Okay, so if you see a kinetic theory of gas questions, explain it, depending lah. I mean, if you're talking about Guy Lussac's law, pressure and temperature, okay, so when the temperature increase, the pressure increase. Why? Because when the temperature increase, the kinetic energy increases. And because the kinetic energy increases, the rate of collision between gas molecules and the walls of container also increases, yang menyebabkan the pressure increase. Basically, what you're doing is you're filling in the gap. Okay, kalau dalam case ini bahkan volume decrease, pressure increase. Sorry, volume decrease, pressure increase. Kenapa? Itu ruangan di tengah itu yang kamu mau isi. Volume decrease, kenapa? Okay, and then yang menyebabkan apa? Yang menyebabkan the pressure to increase. Okay, So kinetic theory, I guess, actually is not difficult lah. Okay, it just requires you to remember. Okay, kalau if I'm talking about pressure, I need to talk about this. If I talk about volume, I talk about this. If I talk about temperature, balik this, sorry. But if I talk about temperature, talk about the kinetic energy. Okay, then you're good to go. So even if kalau kamu tidak dapat sepenuhnya, you get most of it, I think you can still get the mark. Okay, number 6. I think this is the other question that I put a sticker. Oh yes, there's a sticker in this one. Okay, yeah, because it's a very interesting question. This is the only question that I think is interesting. Okay, diagram 6.1, 6.2 show photoelectrons being emitted from a metal surface. Okay, when illuminated by the same light photon. Okay, the same light photon. So this is a little bit strange lah. Okay, the same light photon means that it has the same frequency. Okay, let me remind you, it has the same frequency. Okay, so what is the meaning of a light photon? The definition for light photon is discrete packets of energy. Sorry, discrete packets, okay, of light energy. If you want to take it a step further, it is discrete packets of light energy with no mass. Okay, this is not necessary lah. Kalau kau mau tulis, kau boleh tulis lah. Okay, if not, then don't worry about it. Okay, discrete packets of light energy. So, compare 6.1 to 6.2. 6.1 threshold frequency, 5.15 times 10 14 is 6.03. So, in terms of the threshold frequency, okay, 6.1 is less than 6.2. Okay, the number of photoelectrons, okay, in the diagram is shown, there's 4 here and there's 3 here, like, wow. Okay, so in terms of the number, okay, 6.1 is more than 6.2. Okay, the third one is the photoelectric current. So take a look at this. This milliammeter. So milliammeter, the 0, if you take a look at this, the 0 is on the left side. Okay, so which means that 6.1 ini lebih besar daripada 6.2. Okay, so the current 6.1 is bigger than 6.2. Okay, I think it's pretty easy lah. Okay, based on your answer in 6B, okay, based on your answer in 6B, okay, state the relationship between the threshold frequency and the number of photoelectrons emitted. Okay, so if we take a look at this, okay, it's asking us to relate these two lah, makan. And our usual practice is, okay, because the direction is opposite to one another, so the bigger the threshold frequency, the smaller the number of photoelectrons emitted. Okay, which is what I would write. Okay, the bigger the threshold frequency, okay, the smaller the number of photoelectrons emitted. Okay, I mean the relationship is very obvious, okay, from these two comparisons. Semakin besar frekuensi ambang, semakin kecil lah, okay, bilangan photoelectron. However, so why did I put this binocular sticker over there lah? Okay, because in reality, okay, in reality, the threshold frequency does not affect the number of electrons emitted. Okay, we established this, I think, in the previous class. We said that the number of photoelectrons that you emit is not actually dependent on the threshold frequency. Threshold frequency menentukan sama ada the photoelectrons will emit or not. That's it. Sama ada dia akan terbebas atau tidak. Okay, what determines the number of electrons is, what determines the number of photoelectrons is, is the intensity of light, the keamatan cahaya. Itu yang sebenarnya menentukan bilangan elektron yang terbebas. Okay, so this is a very interesting question because actually the relationship yang saya tulis di sini dalam soalan ini ya, okay, according to the question is correct. It looks like it lah. You compare, then okay, the higher the number of this one, the higher the threshold frequency, the smaller number of photoelectrons. But in reality, okay, sebenarnya yang kita sepatutnya belajar is the threshold frequency is not affecting the number of photoelectrons. Okay, it doesn't mean that if you have a higher threshold frequency, dia punya bilangan lebih banyak. It just means that it's easier to release the photoelectrons. That's it. Okay, so this brings us to the question lah. What happens kalau begini berlaku dalam exam? Okay, kamu menulis satu ayat, okay, the ayat dalam warna biru bahkan actually is false. It's not true. Okay, dia betul kerana kita buat comparison begitu. We do this comparison and oh wow, okay, fine. It seems that there's a relationship. Okay, but in actual fact, the right answer should be the pink color one. Okay, so in the exam, if this happens, okay, I would say that choose one answer to write. Okay, because of this, okay, I think that the people who mark your papers, obviously they're all physics teachers lah, they can't be just like not random people lah. They're also physics teachers. Okay, and I'm very sure that one of the markers, okay, will also figure out that kenapa ni ayat ni macam salah, because the number of electrons is not affected by the threshold frequency. Okay, I also check in Google lah. Okay, I check in Google and say no, it doesn't. Okay, only the intensity of the light does. But okay, so what you shouldn't be writing is both answers. Sebab if you write both answers kan dia macam bercanggahan. Satu ada relationship, satu tiada relationship. Bagus lagi kamu tulis yang warna biru daripada kamu tulis kedua-dua. It's better to write just the blue even if it is like wrong. Okay, it's better to write the blue than to write both. You can write the pink color also. I think it's fine. Okay, but don't write both answers because both answers adalah bercanggahan. Never write jawapan yang bercanggahan. Okay. Okay, back to our story. Number of photoelectrons and the photoelectric current. Okay, this one makes a little bit more sense lah. Okay, the bigger the number of photoelectrons, okay, the bigger the photoelectric current. I think this is very straightforward. It's also shown in our this one lah. Okay, predict the kinetic energy of the photoelectrons when the intensity of light increases. Okay, we spoke about this in the previous class. Saya cakap kinetic energy depends on the energy of the light, not on the intensity. Okay, or depends on the frequency or the wavelength of the light lah. Okay, so it doesn't depend on the intensity. Intensity mempengaruhi bilangan elektron. Okay, the number of electrons affects the is affected by the intensity. So in this particular question, once again, okay, the answer is unchanged because there is no relationship between intensity of light and kinetic energy. Okay, so please remember the relationship. Intensity, number of electrons. Light frequency or light wavelength or light energy, kinetic energy. Okay, so please make sure that you get the pairing correct. Calculate the work function for 6.1. Work function is the H times the threshold frequency. Okay, so the H is 6.63 times 10 negative 34. Ini memang ada diberi dalam formula list. Okay, 6.1 is this, 5.15 times 10 to the power of 14. Okay, and we'll get our answer 3.414 times 10 to the power negative 19. And because it's a work function and it is a form of energy, it's still going to be joule. Okay, so work is energy. Work requires energy. Work is joule. Okay, just like energy. Okay, number 7. Wow, we are at number 7 already. Okay, diagram 7.1. Okay, shows an air conditioner labeled 240 and 1500 watts. What is the meaning of 240 and 1500 watts? We've said this many times. Kita nampak ini. Soalan ni kan macam sentiasa akan keluar. Okay, so please remember the standard answer. Okay, when the peranti ini air conditioner. Okay, when the air conditioner is supplied. Okay, bila dia dibekalkan with a 240 volt voltage or potential difference, okay, it releases or it produces 1500 joules of energy per second. Okay, we see this definition so often, okay, that I think it's worth remembering this, okay, because all you have to do is just change the number and change the alat. Because this is aircon, kita cakap aircon lah. Kalau they like if it is an oven, oven. If it is a hair dryer, hair dryer. Okay, but the format doesn't change. Okay, calculate the electrical current. Okay, electrical current. If you notice here, you're given the volt, you're given the power. The formula is P equals to VI. Okay, power is 1500, V is 240. You can calculate the I is 6.25 amperes. Okay, I think this is a very simple calculation. There's nothing much to this lah. Okay, 6.25 amperes. Okay, table 1 shows the comparison between three types of air conditioners. Okay, so this is how physics is like already lah. You also have to know about what's happening with air conditioners. Okay, so penyongsang, we call this inverter, okay, and non-inverter. So generally we kind of like inverter lah. Okay, inverter air condition because it is known to be energy saving. Okay, so save electrical energy, less heat energy release. Okay, or there's less heat loss, things like that lah. Okay, in terms of electrical power, kita mau yang lebih besar lah. Siapa lah mau beli kalau electrical power of the aircon is so kecil? Kamu mau sejukkan bilik makan, so you need more power. Okay, and of course, nowadays we can't live without Wi-Fi. We can't even have this class if we don't have Wi-Fi. Okay, so of course we want Wi-Fi lah. So it looks like we're going for R. Okay, so air conditioner system is inverter. Okay, and inverter usually is energy saving lah. Energy saving. Okay, you can actually do a comparison. If you go to the aircon shop, you go and see lah. Kalau inverter kan, dia punya bintang-bintang itu kan banyak itu. Usually 5 or 4 stars. But if it's a non-inverter aircon, 3 stars, 2 stars, not very energy saving. Okay, but if you want a little bit more technical answer, okay, less heat energy release. This is also a good answer. Sorry, less heat energy release. Kurang pembebasan haba. Okay, electrical power, high electrical power because we can't help it lah. Okay, we need to have more cooling effect. Okay, so what's the purpose of this one? Dalam bilik yang besar dengan cekap. Okay, large room efficiently. Okay, so we want high electrical power because it's a big room. Okay, so we can decrease the temperature. Okay, decrease the temperature of the room in a short time. Okay, it takes a shorter amount of time to decrease the temperature in the room because it has high power. Okay, kalau dia low power kan sikit lah dia punya udara keluar kan. Low power is usually good for a small room, like bedroom. Then low power aircon is good enough. Okay, you don't want too high of a power lah. Okay, network adapter, as I said, Wi-Fi. Obviously, the answer is because we cannot live without Wi-Fi. Please don't give that kind of answer, okay? Because we cannot live without Wi-Fi. No lah, what's the purpose of a Wi-Fi aircon? Okay, so you can control the air condition, remotely. Like you're driving in the car. Okay, sorry, you're driving in the car. No, let's say you're in the car, right? And then like, okay, I want to prepare my room for aircon so that when I come home, they're on to the. Okay, so you turn on, you just. Nowadays, everything is, at your fingertips lah. Well, at your handphone lah. Okay, so you can control. Okay, can control the aircon conditioner. Okay, remotely. Okay, yeah. Okay, from a very far away place lah. Okay. Okay, so based on our answer, the best one, the best aircon is type R. I think it's pretty easy lah. Sure. Okay, next, number 8. Uh, Electromagnetic wave with a frequency of 2.45 times 10 negative 9 hertz. Okay, so what is the meaning of electromagnetic wave? This is one of the more difficult definitions to remember. It is a wave that consists, of electric field and magnetic field. That's why it's called an electromagnetic wave. Okay, electric field and magnetic field that oscillates perpendicularly, okay, to one another. Okay, yeah, this is a difficult definition to remember. Okay, but basically, yeah, one up, one down lah. Okay, calculate the wavelength. I think this is standard. Every time you see a wave question, there has to be a usage for this formula. V equals to F lambda. Okay, the F is given to you. Okay, kan tadi, the F is 2.45 times 10 to the power of 9. 2.45 times 10 to the power of 9. Okay, and then there's the wavelength lah, lambda. Itu yang kau mau kira. The question is, what is the wave speed? Okay, so this is the other thing you need to remember. An important characteristic of electromagnetic waves, okay, is that they travel at the speed of light. Okay, and if you don't know what the formula for the speed of light is, never fear, because, well, I hope so lah. Oh no, it's not given. It should be given though. Speed of there. Here we are. The speed of light, okay, is 3 times 10 to the power of 8. So never fear. Except that dia punya huruf adalah huruf C. Itu saja pun. Okay, but the speed of light is 3 times 10 to the power of 8. Okay, so this is an important characteristic to remember. Electromagnetic waves travel at the speed of light, and only electromagnetic waves. Okay, the other waves, water waves, sound waves, different speeds. Okay, electromagnetic waves travel at the speed of light. So after you do this calculation, you get lambda equals to 0.122 meters. Okay, so this important thing to remember lah. All right. 8.2 shows a communication device that is used at a hilly camping site with no communication coverage. Okay, fine. People like to go camping to healing away from it all. Sure. Okay, the wave frequency. Okay, since you want to communicate clearly and because it is so far away with no communication coverage, you want to have a low wave frequency. The main reason for low wave frequency is to have high wavelength. We want the high wavelength waves. Okay, for example, like radio waves. Radio waves are big wavelength. Okay, kenapa big wavelength sangat bagus? Okay, you can also say better diffraction, okay, of waves. Okay, senang untuk dia terbelau, senang untuk dia, like go somewhere. Okay, dia bukan terpantul balik. Okay, but the main reason why I would choose low wave frequency is because of its high wavelength. Okay, remember the relationship. Wavelength dan frequency adalah berkadar songsang. Okay, kalau satu tinggi, satu rendah. Okay, antenna, obviously, kalau kita tengok antenna ni, punyalah kecil. Okay, let's have a longer antenna lah. Okay, why do we want a longer antenna? Okay, better signal. Okay. Okay, better signal can be received. Okay, can be received or sent. Kamu boleh hantar dan kamu boleh terima signal yang lebih baik. Okay, better coverage. Okay, so another reason for antenna, okay, another reason for antenna is better coverage lah. Okay, Uh, anyway. Okay, additional features to communication device. I love this question because it's so open. You can think about anything. Okay, there's so many things I can think of. You can say the standard one is low density. Sorry, low density. Okay, or another one is okay, fine. You know what? Let me just give it to you. I take it from the marking scheme. Okay, waterproof. Uh, Let me see. Waterproof. Yeah, I think that's a good one. Have an alarm. Okay. Uh, Wait, hold on. Communication device. Yeah. A better battery life. There's so many things that you can do, but ini adalah soalan kebat kan yang sangat terbuka. Like anything that makes sense to you, this is the time to do it. Okay, and I hope there's a lot of questions like this because it's really, it's like basically free mark. Okay, except that we need to be careful about the reason. Okay, low density generally is smaller mass. Okay, we want low density for a smaller mass. Why do we want it to be waterproof? So that it lasts longer. Okay, or like right at the moment when you want to communicate with somebody kan, terus dia rosak because sudah kena masuk air. Okay, so we don't want that lah. That's what we don't want. Okay, you install an alarm. Okay, so that it can, what it says here. Oh, okay, to warn. Okay, in an emergency. Okay, kalau ada emergency, bolehlah kasih warning. Better battery life. Okay, so can be used for a longer time. Okay, question number 9. Okay, diagram 9.1 shows an electron produces thermionic emission. Yay, we haven't had a thermionic emission. Okay, so if you remember from our previous class, thermionic emission is the emission of electrons. Okay, when a metal surface is heated. Okay, kalau photoelectric is pembebasan elektron apabila cahaya of a certain frequency lah dengan satu frekuensi tertentu dipancarkan ke atas permukaan logam. When you illuminate light on the metal surface, emission of free electrons. So obviously the definition is the most important thing in thermionic emission. Okay, the emission of electrons from a metal surface. Okay, and then the syarat. Okay, when it is heated. Okay, there we go. Given a charge of an electron is 1.6 times 10 negative 19. Okay, the mass of an electron is 9.11. Kinetic energy when the EHT is used is 5 kilovolts. Okay, let's first talk about this. In terms of thermionic emission, okay, dia memang akan ada kaitan dengan kinetic energy. However, the formula that we learn is that the electrical potential energy is EV. Okay, this is almost the same situation actually yang macam yang roller coaster tadi itu. This one. Okay, the mgh equals to half mv squared. Something equals to the kinetic energy. Okay, so something equals to kinetic energy. Okay, in this case, it's not gravitational potential energy, but rather it is electrical potential energy. Okay, electrical potential energy equals to the kinetic energy. This is the standard for thermionic emission. So, since you're given the voltage and you're also given the charge of an electron, I can also say that the kinetic energy, okay, is the same as EV. Okay, the 1.6 times 10 negative 19 times, okay, change the 5 kilovolts to 5,000. Okay, times 5,000. okay, which you will get about 8 times 10 to the power of negative 19. I think it's negative 19, 19 or, oh no, 16. 8 times 10 to the power of negative 16, okay, joules. Sebenarnya yang kamu kira ini adalah electrical potential energy. But because of the formula of thermionic emission, the electrical potential energy equals to the kinetic energy. So yes, walaupun dia suruh kamu kira kinetic energy, but you don't have enough information to calculate kinetic energy kalau kamu mau guna half mv squared. You don't have the velocity because that's the other thing they want you to calculate. Okay, so this is kind of like a trick question, but not really a trick question. It tests lah. Dia sebenarnya menguji kamu, do you remember that the kinetic energy equals to the potential, the electrical potential energy? Okay, in other words, to keep it short, kalau dia suruh kamu kira kinetic energy, just calculate EV. You're good to go. Okay, then you can calculate the maximum velocity because the EV equals to half mv squared. Okay, saya ambil dari sini. EV is 8 times 10 to the power negative 16. Half, what is M? M is this, 9.11 times 10 negative 31 V squared. Okay, we are seeing this question for the second time. Mengira itu V squared. Don't forget to square root the V. Okay, you will get V equals to 4.191 times 10 to the power of 7 meters per second. Okay, we're good to go. Okay, it's not a particularly difficult question, but just requires us to remember this formula. Okay, let me just check and see whether the formula is given in our formula list. Oh, there? Here we go. Ada pula. Okay, it's right here. Okay, except that you have to remember that they're related to one another. Okay, let's continue. Next question. 9.2 shows a Maltese cross tube, okay, over here. So what is formed on the fluorescent screen when S1 and S2 are closed? Okay, explain your answer. Okay. I don't know whether you remember this, but there was one time that I showed you the video of Maltese cross tube, where if you on one switch, then it's just yellow light. And if you on the second switch, then it becomes green. Okay, that's basically what we want the answer to be. Okay, when you switch on S1 only, you get the first shadow. Okay, the first shadow, which is the yellow color one, the black one. This, when you on the second switch, okay, you get the black shadow also, but the color of the screen now becomes green color. Okay, because of the pentafloor screen. So let me give you this one now. Okay, the first answer has to be 2 shadows will be formed. Okay, the first shadow is because of switch S1. Okay, so the first shadow is formed because the light ray is blocked by the Maltese cross. Okay, the Maltese cross blocks this one. Okay. The second shadow, which is the green color one, okay, the second shadow is formed because the electrons hit the pentafloor screen. Okay, the pentafloor screen is here. Okay, the second shadow is formed because the electrons hit the pentafloor screen and creates a fluorescent effect. How do I spell fluorescent? F-L-U F-L-U-O-R-O F-L-U-O-R-E-S-C-E-N-T. Does it look correct? Fluorescent. Something like that. Okay. Fluorescent effect. Okay, 1 mark, 2 mark. Oh, okay. Then we have to talk about why does it create the fluorescent effect? Because of the high energy. Why does it have high energy? Because switch S2 turns on the extra high energy. Okay. Switch S2 provides EHT, which is extra high tension, that accelerates the electrons to high kinetic energy. That's why it can hit the screen and create the fluorescent effect. Okay. Yes, this is a particularly difficult, not very routine kind of explanation lah. Okay. I'm pretty sure there's a simpler version of this. Maybe in your black book got lah. Okay, but I want to be as close as possible to the question because they asked about S1 and S2. Sorry, switch S1 and switch S2. Yeah, so I talk about those lah. The first shadow is yellow because it's just the light being blocked. Second shadow is green because of the electrons that are accelerated. Okay, oh sorry. The next question, D. Okay, cathode ray oscilloscope connected to an incomplete rectifier circuit. Okay, so this is a not very popular question this year, but you never know lah. Okay, so remember the rectifier circuit there are two kinds of rectification. Okay, rectification got two types. Rectifikasi ada dua jenis. One is a half wave and the other one is full wave. Okay, half wave is two diodes. Full wave is, half wave is one diode, one diode. Okay, full wave is four diodes. Okay, yang arrange yang macam diamond itu kan. So that is what we need lah. So rectification is changing from AC, okay, changing from alternating current, converting from alternating current to direct current. That's the definition of rectification. Okay, so let's see. Box X. Now I kind of regret putting this page in the middle. I have to strike twice. Okay, box X is over here, 240 volts. We want to go to 9 volt. So we need to have a step down transformer. Obviously step down lah. Okay, because kita mau pergi daripada 240 kepada 9. Okay, so the reason, I'm going to write the reason terus lah. The reason for step down transformer is to decrease. Okay, to decrease the output voltage from 240 volts to 9 volts. Okay, to decrease the output voltage from 240 volts to 9 volts. Okay, then in box Y, astaga, box Y. Okay, box Y is over here. Obviously, we want to rectify this lah. So we want to have for this one. So we want this or this. Okay, so at this point, I should talk about this lah. Okay, so how do you answer this in the exam? Sama sudah lah di ruangan essay bahkan yang macam ni. So how do you answer this? Do I have to describe this one now? Okay, 4 diodes arranged in a diamond and the direction is like that, like that, like that, like that. Actually, you can just draw it. I don't think it's a very big issue lah. Okay, which is why the table method works because you can draw. Okay, imagine now if this is like a real essay question. How are you going to describe this in an essay? Okay, 4 semiconductor diodes, and then they arrange so that the first triangle is pointed northeast, and the second triangle is pointed southeast. Astaga, no. Okay, that diagram is helpful. Okay, so just draw the diagram. I think it's not a big deal at all. But of course, the reason is more important. Okay, so why do we want 4 semiconductor diodes arranged like this? Okay, so that you can get a full wave rectification. Okay, getting a full wave rectification. Okay, Next, box Z. Okay, box Z over here, usually we will have a capacitor lah. Okay, usually we will have a capacitor. So the capacitor obviously has to be in series. No, in parallel. Okay, box Z has to be a capacitor in parallel with the resistor. So what's the function of the capacitor? The function of the capacitor is to smoothen the output current. Okay, and so because it smoothens the output current, so this will be our answer for the CRO wave pattern. Okay, which gives us R lah. Okay, R as the best answer. So why is it that we want a smoothen this one? Okay, so that the current supplied is stable. Okay, stable current supply. Okay, which is what we want. Because remember, why are you making this choice? You are making this choice because you want to charge your smartphone. Okay, you want to charge your smartphone. So the last thing you want is an unstable current supply, okay, which will cause a lot of damage to our phones. Okay, so please thank God for the creation of the capacitor. The capacitor really helps us to stabilize our current. Okay, so you get stable current supply, stable potential difference. I think that's not so bad also. But don't talk about full wave rectification because it's not. It's already smoothened already. Okay, so the best choice is R, and as I said, and I will always say, please don't forget your 9th and your 10th mark. Okay, in the table. Make sure you complete the table before you do this one. Wow, there's still people come. Oh, gone. Okay, next question, number 10. Diagram 10.1 shows an image form, okay, when light rays from object propagate, okay, through a convex lens. The focal length of the convex lens is 12. Okay, still one characteristic of the image. All you have to do is just look at this image and tell me what it is. Okay, obviously it's a rail image. Okay, any one of these answers is fine. It's rail or it's inverted. Okay, how do you know it's inverted? Because the original is pointing upwards. Okay, inverted is pointing downwards. So it's inverted and it's also diminished. Okay, lebih kecil daripada objek. Okay, I think this is not this either one also can. Sure, you can answer all three. I don't think it's a very big issue. Okay, but make sure you get at least one correct lah. Okay, the linear magnification. There are two formulas for linear magnification. Let me see if it's there. It should be there. If it's not, oh no. Okay, linear magnification. There we go. V over U. Okay, V over U is the linear magnification, which is the image distance. Okay, this is V and this is U. Okay, your job is to know which is U and which is V. Okay, object distance is U, image distance is V. So the linear magnification is V over U, which is 18 over 36, which will give you 0.5. Okay, there's no unit for linear magnification. The other formula, which is not given in your formula list, is that the linear magnification is also the image height over the object height. Okay, high over whole. Okay, high over whole. And since you are given the height of the image is 3 and the linear magnification is 0.5, therefore you can say that 0.5 equals to 3 over the height of the object. Okay, you can get the height of the object equals to 6 cm. Sorry, 6.0. Okay, 6 cm. Oh, she's here. Yeah, I really have to edit this out. Okay. Okay, 6.0 cm. Yeah. So there's a reason why I'm writing this 6.0. Why is it that we cannot just write 6? Because if you notice from the beginning of the question, it's 12.0, 36.0, 18.0. I think it's a very strange thing that they put it like that. And so I noticed that, even in the question, it says 3.0. Okay, so I think just to be on the safe side, I will write the answer as 6.0 just to be consistent with the rest lah. Okay. Okay, explain how lens can be used to rectify short-sightedness. Obviously, the first thing you need to talk about is which lens. Okay, convex lens is not for short-sightedness. People like me with short-sightedness, rabun jauh bahkan. Rabun jauh tidak boleh nampak jauh, so I need the concave lens. So the first line is the type of lens used is concave lens. Ini penting. Okay, then after that, the light will diverge, okay, after passing through the lens. Okay. Do you remember the question that we did the other day? Not the other day lah. Apa itu? Yesterday, 2 days ago. Yang kita buat itu MRSM. Sorry, SBP. Remember the question was, there was a concave lens and then your eye. Kan? Oh dear. What is this? Okay, this is your eye. Kan? So they diverge so that it can converge. Okay, so it adjusts the diverging so that they boleh converge and form at your retina. Okay, so this is why, this is same question again. Okay, 2 times already, guys, we're seeing this question. Red or green or purple or whatever flag that you want lah. Okay, so the light will diverge after passing through the lens. Okay, and then the diverged light, okay, the diverged light, yang cahaya yang sudah tersebar itu, okay, the diverged light will converge, okay, after passing through the eye lens. Okay, kanta mata, kamu punya mata lah. Okay, then the image will be formed at the retina. Okay, something that you learn in science lower form. Once again. Okay, so the image will be formed on the retina. Okay, and then sent to the brain, and then etc. lah. Okay, so but I think okay, if you get lost in this lah, okay, if you get lost in this, I think the more important thing to remember is jenis kanta apa yang kamu perlukan. Okay, untuk rabun jauh is concave lens, untuk rabun dekat is convex lens. Okay, I think this is a very important thing. And again, now we see this kind of question taking stuff from lower form science, okay, to test you on this. The actual thing that you only need to know that is actually physics, okay, is point number 2 and point number 3. Itu saja yang physics sebenarnya. The first point and the fourth point is from lower form science. Okay, so we cannot forget what we have learned in the past. Okay, so that we can do better in the future. Today's moral lesson. Okay, D. Apparatus used to show a simple microscope and normal adjustment in the school physics laboratories. Simple microscope, normal adjustment. Okay, microscope. Okay, oh gosh, we talked about this for so long. Okay, normal adjustment. So, these are facts that you have to know. Actually, yeah, I can't even really say much about this because there's really no choice in this matter. Okay, for microscope, okay, you know what? I'm going to highlight this because it's important. Okay, everything in green, okay, is microscope. Okay, there's a reason why I'm doing this now. Okay, so for microscope, it has to be FE is more than FO. Okay, secondly, okay, the object distance has to be between F and 2F. Okay, it cannot be so far away lah, please. Okay, it cannot be so far away because microscope is so near. Okay, the power of the objective lens. Okay, the objective lens has a very, very, very small focal length. Okay, so the power has to be a high power. Okay, the distance between the objective lens and the eyepiece has to be more than FO plus FE. Okay, this is cannot run away from this. Okay, so obviously the answer that we want is Q and 9th and 10th mark lah. Okay, let's talk about the reasons first. Okay, so for FE is more than FO, the most important reason is you have high linear magnification. Okay, high power, produce bigger image, high linear magnification, I think is the nicest answer lah. Okay, the distance of the object is so that you can produce a real inverted and magnified image. Okay, produce a real inverted and magnified rim lah, rim. Okay, because of our position. Okay, look at our position. Our position is F and 2F. Okay, um, since we're talking about this, okay, we take a short pause just to remind you, kalau ini adalah lens makan. Okay, this is F and this is 2F. Remember the positions of the objects and the characteristics of the image. Okay, if our object is here, then our image is raised. Rail inverted. Sorry, did I say raised? Read. Okay, diminish. Kalau dia di sini, it is raised. Okay, rail inverted, same size. Kalau dia di sini, it's rim. So the reason why we want to have F and 2F is so that you can get a rail inverted magnified image. Okay, this is very standard. Okay, F is virtual upright magnified tapi di infinity. Less than F is virtual upright magnified. Okay, read, raise, rim, boom, boom. Kalau objek kamu di sini, read. Sorry, kalau objek kamu di sini, image kamu akan jadi read. Rail inverted diminish. Okay, nyata terbalik, sorry, songsang dan mas diminish lebih kecil. Okay, raise is nyata, songsang dan sama size. Okay, M is magnified lebih besar, V is maya. Okay, virtual upright. Upright is tegak. Okay, so please remember this. Okay, power of the objective lens. The power has to be high for the exact same reason as this. Okay, the same reason. So I'm going to copy and I'm going to paste here. Okay, high linear magnification. Okay, the distance between the objective and the distance between the objective lens and the eyepiece has to be more than F and FO plus FE. Okay, the main reason for this is to produce, okay, a virtual magnified image. Okay, virtual upright magnified. Yeah, virtual and magnified image. Okay, these are kind of like set reasons, but it's very, very difficult to remember because it's complicated and there's a lot of overlap with telescope. Okay, so kenapa saya highlight tadi hijau and now I'm going to highlight this pink because these are features in the telescope. Okay, not everything here is telescope lah, but for example this one FO and FE, sorry, FO and FE, FO is bigger than FE is a feature in telescope. Okay, I won't go into the reason. I just want you to know the feature. The other feature in this one is the distance is equals to FO plus FE. Ini mesti ingat. Okay. The other two tiada kaitan sebenarnya, but I just want you to know the difference. Kalau mikroskop, cirinya memang yang hijau. Kalau teleskop, cirinya memang yang warna pink. Okay. I really think, and I always say this every year, please spend some time looking at the telescope and the microscope. Because even if it doesn't come out for the essay, there will be definitely something lah, okay, in paper 1 or even in section 8 that will ask you about one of these, okay, telescope and microscope. Okay, spend some time to look at it, okay, and try to understand it. Okay, worst case scenario, tengok saja itu, if you have the black book, tengok itu muka surat yang ciri-ciri mikroskop, ciri-ciri teleskop, and just memorize the answers lah. Okay, at the very least, okay, try to do this. Okay, we're down to our last question. Okay, diagram 11.1. I am at the last question, right? Yeah, okay. Soalan terakhir. Okay, it seems to be this pattern. We've seen this, I think this is like the third time we're seeing this. Question 11, soalan nombor 11 is an electromagnetic question. We seem to be seeing this pattern a lot in the past 3 papers that we've been doing. Okay, I wonder whether it's a sign. I hope it's a sign and I hope it's a good sign for you. Okay, I mean, okay, diagram 11.1, 11.2 show final position of copper rod is the exact same question, I think, as 2 days ago. Okay, so we see this. The only difference is the number of dry cells. Okay, one is 2 dry cells, other dual cell kering. The other one is 3 dry cells. Sure. Okay, what is the meaning of catapult field? Okay, this one we didn't cover, but let's do this. Okay, so the catapult field, okay, is a resultant magnetic field. Actually, yeah, okay, resultant magnetic field produced from the interaction between magnetic field from permanent magnet. Sorry. From permanent magnet and magnetic field from a current carrying conductor. Okay, another slightly difficult definition lah. Okay, it's so panjang. Okay, anyway. Okay, based on diagram 11.1, 11.2, I just want to highlight to you. Let's see how many things to compare. The first thing to compare is the number of dry cells. The second thing to compare is the angle of the deflection. And the third thing to compare is the final position. Then what are they asking us to relate? Relate the number of dry cells and the magnitude, and also deduce the relationship, okay, between magnitude and electric current flow, the magnitude of electric current flow and the force produced. Okay, 5 marks because there's only 5 things you need to say. This is so standard. Okay, and generally it's 3 compare, 2 relationship. Maybe it's 3 compare, 1 relationship, 1 law. Sometimes it can be that. Sometimes it can even be 2 comparison, 2 relationship, and then 1 law. Okay, so it doesn't matter. Let's follow the question. Okay, compare the number of dry cells. Kalau 11.1, 2 sel kering. 11.3, 3 sel kering. So when you compare, this will be 11.1 is less than 11.2. I think this is very simple. The angle of deflection. Okay, this is an ammeter, people. Ammeter starts from 0. The other day, we were looking at galvanometer. Galvanometer, okay, the 0 is in the center. Okay, so be very careful of this difference. Okay, so in terms of the deflection, 11.2 has a bigger deflection lah. Okay, so 11.1 is smaller than 11.2. The final positions of, okay, so yang awal di sini, yang akhir di sini 11.1. Here 11.2 is much further. Okay, so the final position 11.1 is still smaller than 11.2. Okay, dia masih lebih dekat daripada 11.2 lah. Okay, the number of dry cells, relationship now. Number of dry cells and magnitude. Semua comparison kita 11.1 kurang dari 11.2. So everything is directly proportional. Okay, so the bigger the number of dry cells, the bigger the magnitude of current flow. Okay, and the bigger the magnitude of current flow, the bigger the force produced. This is a very simple comparison. Okay, I'm probably overselling this. Okay, the structure of a direct current electric motor. Okay, we just discussed this 2 days ago. I'm giving you the exact same answer over here as 2 days ago. 2 hari yang lepas when we were discussing SBP is the exact same question. Okay, So I'm just going to write down here, refer to SBP 2024 because I want to finish the class early. Okay, so refer to SBP 2024. We just did it 2 days ago. If you didn't do this with me, go and watch the video lah. Okay, it's the exact same question. Okay, I really hope that this question comes up this year because, you know, it will make all this discussion worth it lah. Okay, and having to listen to all these lame jokes that I'm making. Okay, final question. Direct current motor used to turn the tires on a toy electric car. Okay, the question is, suggest modifications that can be done so that it can move with greater speed. Okay, this is a very, there are two ways of looking at this. This is very mean because it gives you no clue how to start, or it can be very good because you are totally free to talk about what you want. Okay, but I don't want to you know, go into too much detail. Suffice to say that I think that you should talk about the coil, like the wire and everything, and you should also talk about the magnet itself. So, you know, we stick to the same few answers lah. Okay, so how do you improve the motor? Okay, how do you improve the motor? Okay, let's talk about the coil first. Okay, in terms of the coil, okay, the one suggestion we can have is bigger diameter or bigger thickness of wire. Okay, bigger diameter of wire. Okay, the reason for this, everybody knows. I mean, I hope you know by now. Why do we want a bigger diameter? Why do we want a thicker wire? To reduce the resistance. Because when you reduce the resistance, you increase the current, you increase the force, the motor spins faster. Okay, a second one is more number of turns. Okay, in the coil. Why more number of turns? You know, you can say to increase the force. Okay, yeah, to increase the force lah. Okay, or to increase the rotation lah. Supaya yang ini motor bahkan dia berpusing lebih banyak lagi. Okay, higher number of turns, more number of turns in the coil to increase the force. Okay, another one is, of course, our favorite friend, copper wire. Why do we want copper wire? Reduce resistance. Okay, another one, why do we want thicker wire? Oh, thicker wire saya sudah cakap pula, sorry. Another one is low resistivity. Okay, kalau kita cakap low resistivity, remember guys, okay, notice that over here I'm writing resistance. Di sebelah kiri saya tulis resistivity. Supaya saya boleh pelbagaikan saya punya jawapan. Jangan sesekali letak di sebelah kiri low resistance, then ada pula di sebelah kanan low resistance. Jangan. Okay, so kita ubah saja tu perkataan sikit. We just change the word resistance to resistivity. And it gives you a whole new answer. Why do we want low resistivity? So that you can get higher current or bigger current. Okay, so please be very careful. Make sure that the words on the left and the right don't appear in both sides. Okay, kalau atas dan bawah sama, no problem. Kau tengok ini dan ini same. Sure, go ahead. Okay. Okay, that's about the coil. Let's talk about the magnet. Okay, magnet saya rasa lagi senang. Let's talk about the magnet. Okay, in terms of the magnet, of course, we want stronger magnet lah. Okay, why do we want a stronger magnet? To increase the force. Okay, or stronger catapult field. Okay, this is standard. Another one is apa itu? Circular magnet. Cylindrical lah. Okay, cylindrical magnet. And the general answer for cylindrical magnet is to produce a radial, okay, magnetic field. Okay, supaya tiada kehilangan medan magnet. Okay, If you remember from the previous class, okay, the magnet that we use is called a neodymium. Okay, ini adalah jenis magnet lah. Okay, a neodymium magnet because it has a stronger magnetic field. It's one of those magnets with a very big magnetic field lah. Okay. Now, how do you answer this? Because you are only allowed 5 lah, okay? Can you give all 7 answers? Yay! Of course you should give all 7 answers, especially if you've memorized them. Why limit yourself to 5? Okay, answer all 7. But in case lah, okay, in case you run out of time or by some funny reason you feel very lazy to write all 7 answers, I suggest a combination of 3 coil answers and 2 magnet answers. Jangan 4-1. Okay? 3 coil, 2 magnet is your very minimum. You should do this kind of combination. Okay? Why? Because dalam soalan dia bagi kamu satu clue. It's not a very obvious clue, but it is a clue nonetheless lah. Okay? Coil, kamu bagi 3 ciri, magnet, kamu bagi 2 ciri. You can flip it the other way, but you got more choices for coil, and it's easier to memorize for coil. Okay, I just want to add one last answer, okay, before we call it a night, which is about the motto itself. I want to talk about the motto. Okay, this one I got from the marking scheme lah. Okay, so in terms of the motto, in your textbook, actually, there's this thing called the brushless motto. Okay, the reason for brushless motto is to produce less heat. Okay, because there's less friction. Less friction means less heat, so it's more efficient. Okay, the other one is also low. This is very funny lah. Okay, low density motor casing. We can't do much about the motors, about the magnet, but we can do something about the penutup. Okay, yang bikin tutup itu adalah low density because so that it has a smaller mass. Okay, I think if you answer, if you answer all these table questions often enough, you can kind of goreng your way through any question lah. Kan balik-balik low density. Why low density? Smaller mass.